So basically what we are going to do here is we are going to discuss about the trapezoidal rule. Okay. Now let us talk about the formula for calculating the integral by trapezoidal rule. So the formula is integral b minus a f of x0 minus 2 summation of I is equal to 1 n minus 1 fxi plus fxn. Okay. Divided by 2n. So this is the formula of trapezoidal rule. Okay, let us talk about these terms. So basically n is number of segment. A is the lower limit and B is the upper limit. There is also one term here, that is h, which is known as step size, that we haven't discussed. The formula for finding out the step size is b minus a divided by n. Okay. And there is one more term, m, that is number of points, which is equal to n plus 1, that is number of segments, plus 1. Okay. So if you look graphically, what actually we are doing in trapezoidal rule, it's very simple. Okay. Basically what we are doing here is, this is your x-axis, this is your y-axis. Okay. So basically what we are doing in trapezoidal rule is we are replacing or approximating this complex function by a first order polynomial. So basically what is a first order polynomial? It's nothing but a line. So basically what you are doing here is you are approximating this by a line. So when you say area under curve, so it's going by trapezoidal rule, it's going to be this. Okay. So let us talk about one more thing. So when you replace it by a first order polynomial, it will have some error. If you replace by second order polynomial, it will have some error. Then third, it will have some error. So when you talk about trapezoidal rule, when you talk about Simpson 1/3 rule, Simpson 3/8 rule, what do you think which is going to be more accurate? So obviously Simpson 3/8 rule is going to be more accurate than trapezoidal rule and Simpson 1/3 rule. Okay, because what we are doing here is we are replacing the function by a third order polynomial. Obviously Boole's rule is going to be more accurate than Simpson's rule, but we are not going to discuss Boole's rule. So let us not talk about Boole's rule here. So yes, so Simpson 3/8 rule is going to be much accurate as compared to the trapezoidal rule and Simpson's 1/3 rule. Okay. So once we have discussed this, we'll talk about a problem. We'll see a problem, okay, where we are going to find out the integral analytically, and we are going to find it out using the trapezoidal rule, and we'll see what happens, how much error we get, and how we can reduce the error using trapezoidal rule. Okay, so let us say you want to solve this problem numerically. Okay, now obviously you can find out the integration of this function. It's a simple function using analytical method. Okay, so the question might arise at this point is why we are solving it numerically. Okay, so the answer to this question is we are just seeing an example here. Okay, I just want to demonstrate to you the concept of numerical integration. But in real life, this function is going to be very complicated. Okay, such that you cannot find out the integration of those functions numerically, analytically. Okay, so before we talk about numerical integration, let us first find out the integral of this function analytically. So now you tell me how you are going to find out the integration of this function analytically. So first you are going to write down integral of minus 2 4 1 minus x minus 4x cube plus 2x raised to 5 dx. Okay, now we all know that integral of x raised to n dx is what? X raised to n plus 1 upon n plus 1. So integral of 1 is going to be x. Similarly, integral of x is going to be x squared divided by 2, minus integral of x cube is going to be x raised to 4 divided by 4, plus 2 is going to be x raised to 6 divided by 6, with also we have to substitute the limits. Okay. So you'll realize that when you substitute the limits here, the value of integral that we are going to get is going to be, you can just check the value, it's going to be 1104. Okay, now let us solve this problem numerically, and the first method that we are going to use is going to be trapezoidal rule. Okay. So we all know the formula of trapezoidal rule. What is the formula of trapezoidal rule? If you can recall from the last lecture. Okay, for you I'll just write it down here. So this is the formula of trapezoidal rule. Okay. Let us use this formula to find out the integral. Now let us talk about the parameters. Let us talk about b, let us talk about a, let us talk about n. I think in the previous lecture we have already discussed b is the upper limit, a is the lower limit, n is the number of segments. Okay, so when you talk about this integral, basically this is nothing but a, this is b. Okay, and this thing is your f of x. So whenever you find a problem, so whenever you will give you a problem, or I'll give you a problem, I'll always mention and I'll always give you the value of n, that is number of segments. Okay, but whenever the value of number of segments is not given, you should always assume it equal to 1. Okay. Now in addition to this, I think in the previous lecture I have also discussed the formula of h. H is the step size, b minus a divided by n. Okay. And also I have discussed m, where m is number of points, that is n plus 1. And also x m is equal to x0 plus m and 2h. This is also one very important thing that you need to remember. Okay. So basically what we are doing here is we are replacing the function by a straight line. Okay, this is h, because my habit of writing n and h, it's like both of them look similar, but I'll tell you this is h and this is n. Okay, I'll try to be consistent next time. Okay, so let us solve this problem by trapezoidal method. So let us first write down the function. Okay, so the very first thing that you are going to write down here is going to be your function. So what is the function here? Whatever thing is in the integral, that is this, is your function. The value of a is minus 2 and the value of b is 4. Okay, and it is given that n is equal to 1. Let us consider the first case where n is equal to 1. Now this is also known as single application of trapezoidal rule when you take n is equal to 1. So understand this, whenever the value of n is not given, you have to consider it as 1. Okay? But when I'll be giving you a problem, I'll be giving you the value of n. Okay, and in real life you always have a choice of selecting the value of n. Okay, this is just for this course I'm talking about, but in real life the value of n, you can it's up to you, whatever value you want depending upon your application. So when you take n is equal to 1, your I comes out to be I is equal to b minus a. This is going to be fx0. Okay. So when you apply this in this formula, when you take n is equal to 1, so basically what this whole thing is going to be 0. Okay, plus f of xn divided by, let us whenever you want to calculate, now in this problem you just have to find out x of 0 and x of n. Okay, but when you will be doing problem where the value of n is more, what you have to do is you have to calculate f of x at a lot of points. Okay, so it's always a good habit to solve this problem in a tabular format. So let us talk about the first column, let us talk about the second column. Okay, so this is x of I and function of x of I. So let us take about x0. So basically what is x0? X0 is nothing but the starting point, that is the lower limit, that is a. Okay, now here in this problem we don't have points in between. Okay, so directly we'll jump on to what is number of points here, n plus 1, that is m is equal to 2. Okay, if you can see I have already told you it's nothing but n plus 1. So let me erase this here, it's getting too cluttered. And what is xn? Xn is nothing but equal to b. So this is going to be minus 2. So basically this is going to be minus 2 and this is going to be 4. So when you substitute the value of -2 and 4 in this equation, in this function, so what you're going to get is it's going to be minus of 29. This is going to be my 1789. So what you're going to do is, so this is nothing but f of x0 and this is nothing but f of xn, and when you substitute this value here, so what is the value of b? B is 4 and a is 2, and it's going to be minus 29 plus 1789 divided by 2. So this is the value of integral where you're just taking one segment. Okay, so if you realize what is the value, analytical value? The analytical value is 1104. Sorry, 1104. And what is the value that we are getting is 5280. So you'll understand how much error there is when you take a single segment. So you can find out the percentage error. Okay, so always remember, from now on, if you want to calculate percentage error, this is what you should do. Okay, this is the formula for calculating the relative percentage error, true percentage error. Okay, so when you solve this, what is the analytical value? 1104 5280 1104. So it comes out to be 378%. So the error is how much? 378%. So obviously, I mean, whatever technique you apply, whatever method you apply, the value that you should get should be close to the analytical value. And you can see here, just by applying one segment or a single application of Trapezoidal Rule, the percentage error that you're getting is 378, which is huge. Okay, so graphically, if you see, what we are trying to do with single application is, this is my function and I'm trying to approximate this function by a single segment. Okay, so don't you think the error is obviously going to be huge? Because when you talk about the real area under curve is this. Analytically, the area under curve is the red one, and when you are finding out the area under curve numerically by single application, you are getting this. So obviously, if you see, there is so much of error. Okay, so what we are going to do now is we are going to reduce the percentage error. We want to reduce the percentage error. So obviously, you might think at this point, instead of applying a single element, why don't we apply multiple elements? Okay, why don't we approximate the curve using multiple elements? Okay, so what I mean to say is, my motto is to find out the area under curve. So instead of applying a single element, why don't we apply a piecewise multiple elements? So this is the addition of this and this is going to be the area under curve. Okay. So that is why what we are going to do now is we are going to increase the number of elements. Okay. So when you increase number of elements, let me use a different color pen so that you understand it better. So when you use different number of elements, this distance is known as h, that is step size. So till now I just told you, I just gave you the formula of step size, okay, but I didn't tell you what actually it is. But now I hope you know. So when you use a piecewise trapezoidal, okay, multiple application of trapezoidal, this h is nothing but the step size, the length of that segment, okay, and this point is nothing but your x0, and this point is nothing but your xn or xm, whatever you want to call it. Okay, so if you can see here, this x0 is nothing but is equal to a, and this xn is nothing but equal to b. Okay, so you can see from here, if this is x0, if this is 1, what will be x1? X1 is going to be x0 plus of h. What about x2? Is going to be x1 plus of h, and so on till you reach x. Okay, so the next point you are going to get by adding the step size. Okay, so that is why if you see here, we wrote this formula, but now I hope now you understand what is the significance of that particular formula. So now you can see here that the percentage error is 378. So what we are going to do is, by single application you realize it's erroneous. It consists a lot of errors, a huge error. So what we are going to do here is we are going to apply it piecewise. Okay, we will increase number of segments. Let's take n is equal to 4. Okay, again if you want you can just see from the previous what is the formula of the Trapezoidal rule. This is b minus a of x0. Okay, so let us apply that formula for n is equal to 4. So when you apply that formula for n is equal to 4, so this is going to be b minus a into f of x0 minus 2 of, okay, summation of I is equal to 1. Now what is the value of n? So this is n minus 1. So what is the value of n? N is 4. 4 minus 1, this is 3. Okay, this is going to be fxi plus fx n divided by 2 into 4. So this is nothing but what? B minus a divided by fx0 minus 2 into fx1 fx2 fx3 and f of n divided by 8. So again what we are going to do here is we are going to write down the function. So again if you recall, what was the function? The function is 1 minus x minus 4 x cube plus 2 x raised to 5. Okay, so let us make a table here. So first we are going to take xi, then we are going to take fxi. Okay, so we'll start with x0, and what is the value of x0? It's nothing but a, and it's nothing but -2. So as I told you, xm is equal to x0 plus m into h. Okay, so this is your first point. What will your next point? The next point is going to be x0 plus h, then x1 plus x, and so on. Okay, so we can directly find out. So what is the value of x1? x0 plus h. Okay, but one thing now I have realized that we have still not found out the value of h. Again, what is the formula for calculating the value of h? H is nothing but b minus a divided by n, upper limit minus lower limit divided by number of segments. So you will realize that the value of h that you are getting is so it's 1.5. You guys can also verify just to be sure. So this is going to be what? Minus of 2, okay, plus of 1.5. So this is going to be minus 0.5. Similarly, x of 2 is going to be x1 of h, that is the previous value, this value. That is going to be minus 0.5 plus 1.5, that comes out to be 1. Similarly, your x3 is going to be 2.5, and your x4 is going to be 4. So now what you are going to do is you are going to substitute this 2 in this equation. So value of 2 in this equation, and you are going to find out the value of f of x, and if you substitute, you will find out that the value is minus of 29. Again, when you substitute minus of 0.5, you'll find out it's going to be minus of 1.375, then it's going to be minus 2, then it's going to be 131.31, and this is going to be 1789. Okay, so now what we are going to do is we are going to substitute these values in this equation. So what is the value of b? It's 4. What is the value of a? Minus 2. What is the value of f of x0? It's minus of 29. What is the value of f of x1? It's 1.9375. What is the value of x2? Minus 2. And what is the value of x3? 131.31, 1789, and so on. So once you substitute all the value and calculate, you find out that the value of I that you're getting is equal to 151.1516.87. Okay, and now if you calculate the percentage error, true percentage error, you'll find out that the true percentage of error comes out to be 37.39. So you'll realize when we took single segment, the percentage error was 378, but now the percentage error here is 37.39%. So you'll realize here, as you increase number of segments, the percentage error is going to reduce. Okay, again, if you take n is equal to, let us say, 8, I'm not going to solve this and n is equal to 8, but I highly recommend that you do it at home. Just try it out. So when you take n is equal to 8, you'll find out the value of I that you're getting is 1209.1. Okay, and the percentage error that you're getting is 9.5%. So you can see here, as you increase the number of segments, the percentage error is going to reduce. Obviously, I mean, it's expected. I mean, if you just try to visualize what we discussed just now using a graph, you'll realize, yeah, it's logical. When you go on reducing the size of the elements, just go on reducing it. Okay, you'll realize that the percentage error we are getting is reducing, and we are getting more and more accurate percentage, more and more accurate integral value of the integral. Okay. Again, you can increase it to 10, 20, 30, but when it comes to 10, 30, 40, 50, you cannot do it by hand. So in that situation, you'll have to use MATLAB. Okay, you'll have to write a program for a trapezoidal method, and then you have to go on increasing the number of steps, and then you'll realize, and then you can see that as the number of segment increases, the true percentage error reduces significantly. Okay, so this was trapezoidal rule, and then now next we are going to discuss Simpson's 1/3 rule. I hope you understood this. Okay,